So looking at our schedule, we're in what I call week 10. The school doesn't, but I don't care. And on Friday, we're going to have a quiz on 4.2, right? And I gave you a perfect example quiz on last Friday. Not last Friday, Monday, right? Monday or Wednesday, I don't remember. So week 11, we're going to have homework 5 due on Monday. And again, I'll write the problems down for homework 5, okay? We're really going to finish chapter 4 Friday. So, but I'd like to give you a little extra time because it's a lot of work. I'd like to give you a little extra time and say that we'll do our test in week 12. So this is the chapter 4 test. And of course, we'll review that Wednesday before. Week 13. And we'll have another quiz on, not well, we're having a quiz this Friday, but also the following Friday, okay? And that will be on 4.3, right? So I'll give you a first derivative test problem. I'll give you a second derivative test problem. Yes? Week 13. Hey, morning. So some of week 11, week 12, and week 13 will be working in chapter 5, antiderivatives, meaning I've taught you how to drive forward, taking derivatives. Now I'm going to teach you how to drive backward, taking antiderivatives. So I'll give you a derivative and I'll say, hey, find me the original function, okay? And so really important for like bio. If you see how something's changing, a chemical reaction or some the body reacting to medicine, you're trying to see what it was like before, right? That's the concept there in terms of applications. You'll do all those applications in Calc 2, right? But it's really not till you get to differential equations, which you won't do as a bio major, but you will do as a engineer. When you're looking at how all these things are changing, can you reverse engineer it and figure out, right, what kind of functions do you have? Almost the same way as like if we could figure out how we could get a rocket through the Earth's atmosphere and then toward the moon, how the hell do we get it back? That's like if you ever saw Hidden Figures, right? And they're calculating all these things. They're calculating things to figure out, is this problem even solvable? If it's not solvable, you better not shoot the rocket out there with a human on it, right? And so that's what we're getting into next with the calculus. We know how things are changing, right? Can we figure out what machine was doing the change or making the change happen? That kind of thing. Week 14 is going to be our chapter 5 test. And so you see there's not a lot of room between the chapter 4 and chapter 5 test. But that's important for me because I want, in week 15, we're only going to review for the final. And we have one day, we're going to take a 5-question quiz. I don't know if I want to call it a quiz because I don't think I'm going to grade it for your grade because they're not my problems. They're the school-wide problems. And so I want you to do well on it because I'm going to report how you did on it to the school. But everyone in the school is taking those 5 problems just to see, are we all teaching at the same level to everybody, right? I don't know if that makes sense, but this is the first time I'm doing this at this school at least. So that week 15, so we'll probably do that on the Friday. So we'll review for the final exam Monday and Wednesday, take that school-wide assessment on that Friday. And I don't want to tell you that I'm not grading it for your grade because I want you I want you to kill it. I want you to do really well on it. There's a limit. There's a Newton's method. There's an application problem like we're doing today. The other two are real simple. I think those three are going to be the challenge. But that's that school-wide quiz, I guess. Assessment is easier, but quiz is quicker to write. And then week 16 is our final exam only on that Monday. Our final exam on that Monday, and we normally start at 10, but we start at 10:15. I'm pretty sure no one's in here before us. So I'll make sure I'm here, have the door open around 9 again, here before 10, just in case you forget. We start at 10:15, okay? So but that's 10:15 a.m. To 12:15 a.m. And then that's it. We don't meet again. So you get our test out of the way for the week, right? How many exams? Did you all look at the final exam schedule and figure out if you have more than one exam on a day? If you don't have more than one class on a day, you can't have more than one exam on that day. It would be pretty rare. But if you go to a bio class after this, or you go to whatever class after this, you could have that exam on Monday as well. 2 exams a day is fair. If it was 3 exams, I would allow you to put it in the testing center. I don't think 3 exams in one day is fair. So if you're like, for me, when I went to school classes Monday, Wednesday, sometimes from morning all the way to night. So I could have had 3 exams easily in a day, but 2 would have been in the morning and 1 would have been in the evening, kind of thing. So, but just communicate with me, right? So that's our schedule. It's so close. I'm telling you, it's going to fly by, and so will life. So try and enjoy it if you can. Homework 5. We're going to have 6 homeworks. So homework 5 due Monday. Eight questions, 8 pieces of paper, stapled, all nicely written, right? You got to follow the book directions. Remember, I told you, it's almost like a crime scene, right? You don't know what the hell happened. It just gives you a function. You got to find where the instructions are. Sometimes they give you instructions for the next 10 problems. They say, find the inflection points for the next 10 problems. So you got to go look for the instructions most of the time, right? I have it here somewhere. I know it's from, I got it. It's from section 4.2 and 4.3. The next homework 6, which will be our last homework, will be problems from 4.6 and 4.1. And then chapter 5, I won't collect any more homework. So 4.2, I have 35, 41, 57, 61. And 4.3, I have 25, 29, 33, 57. It's a lot of work. I'm sorry about that. Just do your best, chip away at it. If you're a day late with a problem or 2, I don't care. I'm not good with deadlines, so I'm not a disciplinarian. Right, my girlfriend's the disciplinarian. The dog will listen to her. She'll sit, do whatever she wants, and with me, the dog's like on the couch watching Animal Planet. Right, it's like lazy. So I come home, she's like, what's happening? All right, I got a problem here from Cassidy to do. Just asking for a derivative of the following. And this is is this one of the homework problems, Cassidy? Where is this problem from? Somewhere in the book. In the book somewhere, okay. So I've got y equals e to the x minus e to the x squared over 1 plus e to the x quantity cubed. Yuck. So we just want a derivative here. So clearly a quotient rule, right? So upstairs function is e to the x minus e to the x squared. Derivative of that is e to the x minus 2x e to the x squared. Do we agree with that? right? Derivative of an e to the x function is in e to the x function. But the inside function, right, I have to make sure I'm doing the chain rule there. So I have to take the derivative of minus x squared, x squared, which is just a 2x, right, derivative of 2x. Downstairs function, 1 plus e to the x quantity cubed, I need 3 times 1 plus e to the x quantity squared now, times the derivative of the inside, which is just another e to the x, right? Derivative of 1 is 0, derivative of e to the x is e to the x. And then I have to think about that downstairs squared, which is going to be to the 6th power. When I'm raising a power to a power, I multiply the powers, right? Nice, so our derivative here is going to come from our quotient rule. And I just got to be really careful here. It's really kind of messy. But I see that I'm going to have this factor times the 1 plus e to the x quantity cubed with a negative in there. I'm going to grab the 3 first. And I have that e to the x minus e to the x squared, that factor, another factor of 1 plus e to the x, but this time squared, and another factor of e to the x. And this is 1 plus e to the x quantity to the 6th. So this is not a problem I assigned to you. Cassidy, this is not a problem I assigned to you, right? Okay. And so you're just looking for the most difficult problems to do? What are you doing? Are you doing the easier ones first? Okay, so just curiosity. It's okay, it's okay. So I have to try and figure out, can I factor anything here, right? And it's pretty clear that I can factor out a 1 plus e to the x to the 2nd power. Do you see that? They both share 2 factors. One of them's got an extra factor, right? So I can take out 2 of those. And of course, that's going to cancel with my to the 6th power. But then what's left here now? So I have an e to the x minus 2x e to the x squared times another 1 plus e to the x. And then I have a minus 3 times an e to the x, right? I'm just looking at what's left over times another e to the x minus e to the x squared. And I'm supposed to work with that, but it's friggin' hideous. It's like, all right, so what am I going to do first? I remember myself as a student going, oh, I don't want to do this, right? But let me look at the answer. Let me look at the answer, and then I'll know how much more work do I actually have to do, right? So I certainly will see that I'm just going to have left a 1 plus e to the x to the 4th downstairs, right? And then I'm saying, hey, can I factor anything else out of there? No. So I'm going to try and distribute. Do you mind if I stop here because I hate this problem? Or do you want me to keep going? Oh, jeez. So I'm going to have to FOIL here and distribute here. So I get e to the x plus e to the x times e to the x minus 2x e to the x squared minus 2x e to the x e to the x squared. That's my foiling. Now my distributing, minus 3 e to the x times e to the x, and then plus 3 e to the x e to the x squared. Again, I'm looking at the answer because I don't want to work on this problem, right? I'm looking at the answer and I'm going, is there anything else that the book did, right? Is there anything else that the book did that I can see that I can do? Well, I'm just going to try and see if there's a like terms anywhere, right? And it looks like I do have like terms, yes? So here I have an e to the x times e to the x and a minus 3 e to the x, e to the x. So that there's like terms. Are there like terms anywhere else? No. Is there anything else I can factor? No. So I'm hoping I'm done with this after this line. So e to the x, I have minus, so by the way, e to the x times e to the x is e to the 2x. So I have a minus 2 e to the 2x. And then I'm just writing everything else here. I have a negative 2x e to the x squared minus 2x e to the x squared plus 3 e to the x squared. Oh, there's a, no, is that, do I have a combination? No. And I'm thinking I'm done here. But you look at the book answer. If you're doing even problems in the book, you can go to the Learning Center, and they have the complete solution manual, so you can see any answer and worked out. Okay? And that's good to keep in mind, because some teachers assign even problems for homework, so you don't have the answers. So I don't think that's fair, but I want you to know the answer, because it could give you a hint at how to approach the problem. So what a hideous, hideous problem. Horrible. Okay, cool. Let me do a second derivative test problem. Yes? Does anyone have a particular problem they want me to do? Or I should just pick one? Why don't I pick one that's actually in the homework? And so when you do it, you'll just you don't want to you don't copy what I do, right? Have it there as a reference. Make sure you do the problem on your own. Yeah, question, Javier? One. Yes. Yeah, that's not a second derivative, but I'll just fine. I can still do it. I don't mind. 4.2, number 57. 57, right? Javert, 57. Yeah. Yep. Good. And so what we're asking for. See how I mean? There's just a function there, and I don't know. Is that an interval? I don't know what that is, right? So I go find the directions. Find the absolute min and max on the given closed interval, right? You see what I mean? You have to go look for the directions sometimes. So yeah. So this is a great problem. I like this function a lot. You'll see it quite a bit in Calc 2. And that's what we're doing. We're trying to get you ready for Calc 2 here. 4.2, number 57. I've got the function x to the minus 2 ln of x on the closed interval from 1/2 to 4. Of course, I can rewrite this function as ln of x over x squared. It looks a little bit more doable there to me. But I want to look at the curve on this thing. I'll use Desmos. So f of x equals ln of x all divided by x squared. So there's my curve. Kind of on your calculator, this one is pretty tough to look at. It's hard to see that it gets gets that maximum there, right? But you can see it a little bit here on Desmos. The way I can stretch it, right? I can really stretch it so you can see that maximum, right? And so I want to restrict my domain here. Again, easy to do on Desmos, not so easy to do on your calculator, but hopefully you're working on that. So I've got a 1/2 is less than x, which is less than 4. There's the piece I want. So it looks like, and so I can do all the calculus now without doing anything. I see the lowest point is going to be at when x is 1/2, right? And I see the highest point is going to be at some critical value of the derivative. Right? Do you see that? So the calculus, look how easy calculus is, right? So easy, right? And so, like when they were first kind of discovering this stuff, they didn't have calculators. Well, they did. They didn't have batteries yet. Joking. 1780 something, right? So they had to do all of the graphing that we do really quick, all by hand. They had to do first derivative test, second derivative test, domain, range, plot points. You had to do everything in order to get the picture of what the graph looked like, right? So, and what about this What about the first derivative test do you see here? What's the graph doing originally? Increasing, and then it starts to decrease. What about the concavity? What are you thinking about concavity here? You think it's down the whole time, and I might agree with you, but yeah, it's coming back. The concavity's change right. Can you see the mouse on the screen? Can you see the little? Yeah, I think right around there is an inflection point. It's hard to see it, but like I said, the calculus. You're going to trust the calculus, right? You're going to do the calculus and then let that be the definitive answer. Okay, so first of all, we'd find f of 1/2. This is a 4.2 problem. Find the endpoints, find the derivative, find the criticals, find the height of the criticals, right? So find the height of the endpoints. So that's ln of 1/2 over 1/2 squared. So that is 4 times ln of 1/2. And that's fine, or you could write it as -4 ln of 2. Either way. Same difference here. Actually, I could bring that 4 inside, right? And then write it as what? Minus ln of what? 2 to the 4th is what? (16), right? But this one's fine. I'm just kind of playing around. I'm using all the things I learned in pre-cal to write things differently and see which one I want to use, right? Basically. I don't really care too much because I know this is a negative number, right? Yeah? So I'm already thinking, if I get a positive, this could be my min. Even though I know the answer already, right? You see what I'm playing with the fact I know the answer already, but I'm letting the calculus happen. I have to find the height of the other endpoint. That's 4, so that's what? Ln of 4 over 16? Yep, 4 squared is 16. I can simplify this. 4 is 2 squared, right? And that 2 can come out, right? You with me? So I get ln of 2 over 8. So I like that answer. Positive, correct? Good. So now all I have to worry about is my critical. Is my critical higher than that or not, right? So derivative, I'm going to use the quotient rule. Upstairs function is ln of x, derivative is 1 over x. Downstairs function is x squared, derivative is 2x. And then the downstairs squared is x to the 4th. So my derivative is x squared times 1 over x minus 2x ln of x all over x to the 4th. It looks like I can cancel 1x here. X minus 2x ln of x all over x to the 4th. And I see I can factor an x, right? So I can factor an x. I get 1 minus 2 ln of x all over x to the 4th. So final answer for my derivative is 1 minus 2 ln of x over x cubed. Now, there's a critical value of downstairs, right? There's a critical value of downstairs there when x is 0. But 0 is not in my closed interval, right? You with me there? So I have a critical of 0, but it's not in between 1/2 and 4, so I don't care about it, right? 0 does not belong to the open interval from 1/2 to 4, so I don't care about that critical at all. But I do get a critical from upstairs, right? I know f prime of x is 0. It tells me that 1 minus 2 ln of x is 0. Hey, morning. Which means ln of x is equal to what? 1/2, beautiful. Which means e to the ln of x equals e to the 1/2. Okay, I'm raising both sides base e, right? So I get x is square root of e. Yeah? Nice. So I found my critical value, and it's a nice way to check it on my calculator. You know, on your calculator, you can just look at the maximum. What is square root of e anyway? About what? About 1.6. And then on my calculator, I can look at that max height. So if you want to go right along with me here. I'm opening my calculator. Looks like I have 26 days left before I get busted for stealing it. In y equal, I'm putting in that original function, right, which was what, ln of x, close parenthesis, divided by x squared. I can change my window to do a nice little trick on it. I can make my min 0.5, my x min. I can make my x max 4, right? So it's a nice way to just cheat that restricted domain. Really hard to tell that it comes back to concave up there. But if you think about it, could it be concave down and getting closer to the height of 0 and never go on? You know what I'm saying? Do you understand that? If it's going closer to 0 and concave down, it has to hit the axis, but it doesn't. So it has to be turning back to concave up in order to get closer and closer to the x-axis as x goes out to infinity. So I can go second. Anybody doing this with me at the same time? So I'm going second, calculate, or the trace button, and I'm going to get my maximum. So I'm going to hit 4. I have to be left of that high point. So I'm going to exaggerate being left of the high point, right? So I'm going to try and get way over here to where I'm really exaggerating that I'm left of the high point. I think about there is okay. So I hit enter. Then I have to go right of the high point. So I'm again trying to kind of exaggerate this a little bit because it's hard to manipulate it or see it. I think I'm right at the high point, and I hit enter, and then I guess. And I'm trying to see if I get close to that square root of e. Yeah, 1.6 something, yes. Yeah, were you okay with that? On the calculator, yeah? You're able to get similar result? The weird part is that left of and right of piece. But this thing is a dinosaur. It's dumb. It's dumb as hell. I did 7 times 3 the other day. You know what answer I got? Low battery. It's pretty dumb. So we're feeling pretty good about this. We still have to find that height at e, right, at square root of e, in the original function. So f of square root of e is ln of square root of e over square root of e squared. Ln of square root of e is 1/2, and square root of e squared is e, so I get 1 over 2e. And then I'm wondering which one is the highest. Well, the easiest way to do it, remember I got what did I get? Ln of 2 over 8 before, right? I don't know which one is higher. I can just turn them into decimals and decide, right? Of course, I can look at the graph and decide, right? Or like if you had a really super strict teacher, they would kind of want you to show that 1 over 2e is greater than the ln of 2 over 8. Which is not too tough to show. So 4 over e would have to be greater than ln of 2. Not really sure how much more I can do here. Maybe I can do this. 4 is greater than e to the ln of 2. 4 is greater than ln of 2 to the e. I don't like it. Sorry. I got distracted. Don't worry about that. Just look at the decimals. Look at the graph, look at the decimals. So I'm not going to write the conclusion up. Is that all right? Javera, if I don't? Yeah, thank you. That's the worst part, right? Writing the conclusion to all of these things. To communicate. That's the hardest part for us humans, right? Nice. Second derivative test. I'll pick a problem unless somebody has one for me. Second derivative test, going once, going twice. All right, I'll pick one. So I'm in the book. I'm in section 4.3. I don't care if I pick one of your homework problems. I don't mind doing that. Let's look at 33 and 57. So 33 says, get me local maxes, but use first derivative test and the second derivative test. Remember, I told you there might be one like that, and they're kind of saying to you, which one do you like better? And it's probably going to be the second derivative test is better. Let me look at 57. Yeah, I like that one. I'll do second derivative test for that one. Even though it's kind of boring. So if you look at the instructions here, right, for the given function, a bunch of the next problems, find the interval where it's increasing, decreasing. That's first derivative test, not going to do it. Find the local min max values. That's first derivative test, not going to do it. Also could be second derivative test, so maybe I'll do that part. Find the intervals for which it's concave up. It's only going to be one interval. It's always going to be concave down, I believe. And then sketch the graph. The sketch the graph part, don't care too much about because we have the calculators or Desmos, right? So let me work on that function because I do like that function, x times square root of 6 minus x. So this is 4.3, number 57, second derivative test parts. And it's f of x equals x square roots of 6 minus x. I have that right? Yes. Nice. So first thing, graph the function. Well, you could. When does it hit 0? At 6, right? It gets a height of 0 at 6, yes? Yeah? So somewhere at 6 there's a 0, and when x is 0, it's a 0. Can I put in a 7 to this function? Can I put in 7? No, because I get a square root of a negative, right? So we're not dealing with any complex numbers, imaginary numbers in calculus, only the reals, which is why we took it out of pre-cal. We took all the complex numbers out of our pre-cal class because we don't use it in calculus. You use it in other branches of mathematics, but not in calculus. So we try to take things out of pre-cal to make it easier so that you can move on to calculus and have a little bit of an easier time with it. So this guy is going to be positive anytime over here, and it's going to be negative for the rest of the way, right? When I put x's or negative in there, you see it's going to be a negative height, right? So, but we should graph it anyway. X square roots of 6 minus x. There it is. So concave down. Do you see it? Concave down? So it's kind of hinting to me, because I'm never going to change concavity, that I don't have any inflection points. And even more importantly, I'm not going to have any critical values, right? Can you kind of visualize that? If I'm going to get an inflection point, I better change concavity somewhere I don't, right? And it's only a one piece of a function, so there's no changing concavity without an inflection point either, right? Okay, first derivative, yes? So first function is x, derivative is 1. Second function is 6 minus x, derivative is negative 1 over 2 square roots of 6 minus x. Yes, you should be doing derivatives that fast now, okay? And so when we're in Calc 2, you have to be able to do them that fast, okay? Because we're learning new stuff, and I expect you to know Chapter 3 completely, right? So derivative here is what? square root of 6 minus x over 2 square roots of 6 minus x. I've got to get an LCD of what? 2 square roots of 6 minus x. So I'm going to multiply this guy by 1 in the form of 2 square roots of 6 minus x. So downstairs, I don't have to think anymore. 2 square roots of 6 minus x. Upstairs, I have 2 times 6 minus x minus another x. So I get 12 minus 2x minus x equals 2 square roots of 6 right over that. So what is it, 12 minus 3x? I don't care too much about factoring out a 3 there because it doesn't change my critical. I care more about factoring out variables than I do care about factoring out a constant. It's your choice, though. You certainly can, but what's the critical? 4, right? So I mean, I can see once I have it factored, I can see the critical right away. So x equals 4 is the C1 value. Because we're going to use our second derivative to show that this is going to give me a maximum, right? We're going to show that the second derivative tells me that this thing is a maximum. Good. Ready for our second derivative. I guess I'll work with this one. So upstairs function is 12 minus 3x. Derivative is negative 3. We okay with that? Yeah, thank you. Downstairs function is 2 square roots of 6 minus x. Derivative is negative 2 over 2 square roots of 6 minus x. So just negative 1 over square roots of 6 minus x. And the downstairs squared is 4 times 6 minus x. 4 times quantity of 6 minus x. We okay there? Good. I need a second derivative with a quotient rule. And I see that my first term is going to be negative, and my second term, right? My first term is going to be negative. Do you see that? And the second term is going to be positive because I got to do the opposite of it. So I'm going to do my second term first. So f double prime of x is going to be 12 minus 3x over square roots of 6 minus x minus 6 times square roots of 6 minus x, all over 4 times the quantity of 6 minus x. Again, you do your algebra the way you do your arithmetic the way you want to do it. I'm doing it the way I want to do it to save like 2 seconds. I picked the positive term first, right? I made sure I put the quotient rule in right, but then I said, hey, in my head, let me put my positive term first. So I have to clear fractions here with a square root of 6 minus x over itself. So I get 12 minus 3x minus 6 times 6 minus x, right? Double square roots, right? All over 4 times 6 minus x to the 3 halves, right? I've got a half power here and I've got a whole power here. So what do I have? 12 minus 3x minus 36 plus 6x. I hope I didn't screw something up. What do I have? I have 3x minus 24. And this is my second derivative. Again, I can factor out a 3 upstairs, but who cares? I can see the critical value of the second derivative is 8, right? But that's outside of my domain. Yes? Remember, the domain was from negative all the way up to 6. If I put an 8 in the original function, I get a complex number. I get an imaginary number. So no criticals of the second derivative, right? No criticals of the second derivative. But I want to use that second derivative, right, to test the value. There's no criticals, so I can pick any value I want. How about a 0, right? I want to test 0, yes? So what happens? I get a negative something, right? Do you see it? Negative? Yeah? So all negative, but I knew that. I didn't really have to plug the 0 in. I could just see that it's always concave down. Oh, I should have tested what? Damn it. What was my critical for my first derivative? What was it? 4? I should have tested 4. Because I don't like killing anything, but I get 2 birds with 1 stone, right? I'll not only get the negative for the concavity, but it'll also show that that first derivative critical value is going to give me negative. Negative people frown. I got to be at the top of a hill. I got to have a local max. Right? So if I plug in a 4 here, what do I get? Negative 12. F double prime of 4 is what? Negative 12 over 4 times 2 to the 3 halves power. Right? So definitely a negative. Yes? Negative 3 over square root of 8. So definitely negative. I don't have to do that, right? You don't have to do that. This is just me being curious. So conclusion now. The second derivative is negative on the entire domain, which means the original function is concave down on the entire domain. I know that the second derivative of 4 is negative. The first derivative of 4 is 0, and f of 4 exists, right? F of 4 exists. What is f of 4? 4 square roots of 6 minus 4. So 4 square roots of 2. So that means that point is a local max, right? F double prime of 4 is negative. F prime of 4 is 0. And f of 4 is 4 square roots of 2. So 4 comma 4 square roots of 2 is a local max. I didn't write the other part of the conclusion just because I'm lazy. What do you think? Nice. Get some of that homework done. It's a lot of work. Don't wait till Sunday. You'll never get it done by Monday. You're going to have to do a problem or 2 every day to get it all done for Monday. Nice. Let's see who came in. Rinaldi's here. Jason B is here. Nahom is here. Asir, yes. Daniel came in. Jeremiah, yes. Karimatu, no. Brian is here. Charlie's here. Sam's here. Giovanni's here. Sam's here. Yabsir's here. Atnal here? Yes, thank you. And Jason Z, yes. Pretty good. Thank you. Good, here we go. New stuff. This is not easy. The stuff I'm about to teach you is not easy. Doesn't mean you can't handle it.